Structural Analysis 2, Chapter 8, Deflections using Energy Methods. Let's solve example in truss with the energy method. So if we have a truss consisting of 5 members like AD, BC, AB, BC, and a vertical concentrated of 50 is applied at B, we want to calculate vertical deflection at point B. Let's see how we can approach our problem. So we want to determine the vertical displacement of joint B, which is here, due to 50K vertical, which applies at the same location. So at the entire structure, there is only one load. Calculate the deflection in the direction of the force. So that's definitely a real method, which is one of the simplest energy method. Just let's approach the problem. So by considering joint B, as soon as you see joint B, there is a 50 kilonewton in the opposite direction to cancel out the vertical force. So if it pulls the point at B, it just pulls the member as well. So this is a tensile member like 50 kilonewton. If after joint B, if we just move to joint B, as you can see here, if is a pulling downward force of FBD equal to 50, these two identical forces should cancel out, so they pushes the joint B here, as you can see in the figure, to have the balance. So you can simply say 2 of the vertical component of FAD or FDC, either of them, is equal to FBD, which is 50. So in that case, FAD is a compressive force of 31.5. You can easily see if there is a force which pushes the joint at D, it should pushes the member as well. So that's a negative 31.5, which means a push to the force. Because these two members are identical due to symmetry, the FC or FCD is also a compressive force of 31.5. Then let's jump to the joint A to see what's happening. Joint A. As soon as you at the joint A, you can see there is a compressive force of FD applied to the joint as well. So the horizontal component of that one should be cancelled out by AX. So AX is 3 of 5 F80, which is a 3 of 5 of 3 point. And due to the direction of AX, you can easily see it just pulls the joint, so it should pull as well. And the new value of that tensile force, it's the tensile force. To symmetry, that's also a positive tensile, 18.75. As soon as we have original truss with forces, then we can apply a member like AD, BC, BD, AB, and BC. Each of the forces, axial forces, the length of each member, then n squared times the length of the member. If you add them up, you will get 21,875. That's the summation of that. Then a half of P times delta of external which applies at joint B is equal to the summation of all members internal energy external work converted to internal energy. So by having that, you can easily cancel out these two with each other. 50 times delta vertical at P is equal to 8 times 1875. It just says delta vertical is 1 over EI times 435.5. Thank you. We'll solve more.